AUTOSAR does not solve every automotive software problem, and saying that it solves complexity is too vague to be useful. Here is a better test. You have an automatic headlamp function working perfectly on ECU A. It receives ambient light information, reads the driver's light switch request, and decides whether the headlights should be requested. Now, management asks you to move the same function to ECU B. The vehicle behavior should stay essentially the same, but ECU B uses another microcontroller, different low-level drivers, another communication configuration, and software from a different supplier. If moving one vehicle function forces you to rewrite large parts of the application, you have discovered one of the problems AUTOSAR was designed to address. Lesson 13 explained why the automotive industry needed AUTOSAR. This lesson is more specific. We are going to identify the recurring engineering problems and connect each one to the part of AUTOSAR's approach that helps solve it. The first problem is unnecessary hardware coupling. Suppose the headlamp application directly reads an ADC register, accesses a GPIO port, manipulates a timer peripheral, and calls a microcontroller-specific CAN driver. The application now contains two different kinds of knowledge. It knows what the vehicle function should do, and it also knows exactly how one piece of hardware implements that function. Those responsibilities are tightly coupled. Change the microcontroller and the functional code may need major modification, even though the headlamp requirement itself has not changed. AUTOSAR Classic addresses much of this problem through architectural separation. Application software sits above the runtime environment, or RTE, while basic software provides standardized infrastructure below. At the hardware-facing end of basic software, hardware abstraction and the microcontroller abstraction layer isolate many peripheral-specific details. That does not make the application completely independent of hardware. CPU performance, memory, peripherals, timing, and safety constraints still matter. The problem AUTOSAR addresses is unnecessary dependency on those details. The second problem is software component coupling. Imagine one application needs vehicle speed from another function. Without a defined interface, the consumer may depend directly on the producer's function name, memory layout, implementation, and ECU location. Now, replace the producer or move it to another ECU, and the consumer may break. AUTOSAR introduces software components and defined interfaces so applications can communicate through architectural contracts rather than depending unnecessarily on one another's internal implementation. The runtime environment plays an important role here. From the application's perspective, the RTE forms the communication boundary between software components and between applications and basic software. Later in this course, we will study exactly how that works. For now, remember the problem and solution pair. Tight software-to-software dependency is reduced by software component separation and defined interfaces. The third problem is duplicated infrastructure. Every ECU needs vehicle-specific application logic, but many ECUs also need recurring system capabilities, communication, diagnostics, operating system services, memory handling, ECU state and mode handling, hardware access. If every ECU project invents completely unrelated concepts for these responsibilities, suppliers repeatedly solve similar infrastructure problems, and integration becomes harder. AUTOSAR Classic provides a standardized basic software architecture containing defined service and abstraction responsibilities. This does not mean every ECU contains every possible AUTOSAR module. Basic software is configured according to project requirements. And it does not mean every vendor's internal source code is identical. The important point is that the architectural responsibilities and interfaces are standardized enough to make integration more systematic. The fourth problem is distributed function integration. Our automatic headlamp function may receive ambient light status from one source, vehicle operating state from another controller, and driver switch information from another input path. The final request may then travel toward an ECU output stage controlling the physical lamps. The vehicle function crosses software and sometimes ECU boundaries. AUTOSAR was designed for exactly this kind of component-oriented and distributed system. Its architecture supports applications distributed across ECUs while maintaining defined software relationships. This matters especially when software modules come from different development organizations. One team can work on the application, another can provide basic software, another can supply the microcontroller, another can configure the network. A common architecture does not eliminate integration, but it gives those teams a shared technical framework. The fifth problem is product variance. A manufacturer rarely builds only one ECU configuration forever. There may be several vehicle lines, trim levels, hardware revisions, and feature combinations. The same functional concept may need to operate with different available resources. Without a configurable architecture, every variation can become another special software design. AUTOSAR specifically emphasizes configurability and scalability. The infrastructure for ECU A can therefore be configured differently from ECU B, while still following the same architectural concepts. Notice what this does not mean. It does not mean one compiled software image automatically runs on every vehicle. Configuration, resource allocation, network mapping, timing, and testing remain project-specific. AUTOSAR makes variation more manageable. It does not make variation disappear. The sixth problem happens before the software even runs: tool and information exchange. An automotive project can involve system architects, software component developers, network engineers, basic software configurators, and ECU integrators. Those engineers may use different tools. If every tool represents the system using unrelated proprietary information, engineering data must constantly be manually translated. That creates another source of integration errors. AUTOSAR addresses this through a harmonized methodology, templates, and machine-readable descriptions, commonly stored as ARXML. ARXML means AUTOSAR XML. It can describe information such as software components, interfaces, system relationships, and ECU configuration. It is not the application algorithm, and it is not executable vehicle control code. Think of it as structured engineering information that participating tools can process. AUTOSAR's methodology describes relationships between activities and work products, while AUTOSAR templates define the formal structure used to exchange that information. So the problem is not only how do our programs communicate, it is also how do our engineering teams and tools communicate before those programs are built. Now put all 6 problems together. Problem 1. The application is tied unnecessarily to hardware. AUTOSAR response, layered architecture, and hardware abstraction. Problem 2. Software components depend directly on each other's implementation. AUTOSAR response, software components, defined interfaces, and the RTE. Problem 3. Every ECU reinvents common infrastructure. AUTOSAR response, standardized basic software architecture. Problem 4. Function spans several ECUs and suppliers. AUTOSAR response, common component, interface, and integration concepts. Problem 5. Product variants create repeated software adaptation. AUTOSAR response, modularity, configurability, scalability, and reuse. Problem 6. Engineering information becomes trapped inside different tools and organizations. AUTOSAR response, methodology, templates, and ARXML exchange descriptions. Now, return to the automatic headlamp function. At the application level, it should ideally reason about meaningful information, such as ambient light level, driver request, and vehicle state. It should produce a logical request, such as headlamp request. It should not need to know, unless there is a genuine project reason, which microcontroller register eventually changes an output pin, or which CAN controller buffer originally carried an input. The lower software and hardware layers deal with those implementation details.
And when electrical power is finally delivered to the lamp, that physical current still flows through an appropriate output driver or power stage. Application software does not directly power the lamp. This is what architectural separation looks like in a real engineering thought process. But there's an equally important question. What does AUTOSAR not solve? It does not decide whether your headlamp algorithm is correct. It does not automatically produce good requirements. It does not guarantee that your task deadlines will be met. It does not automatically make an ECU functionally safe. It does not automatically make the vehicle secure. It does not guarantee that two randomly selected AUTOSAR components will work together without configuration, and it does not remove the need for integration and testing. AUTOSAR standardizes important parts of the engineering framework. Engineers still have to design the product correctly. That distinction gives you a much stronger interview answer. If someone asks,
What problems does AUTOSAR solve? Do not answer with a list of module names. Start with engineering problems. AUTOSAR reduces unnecessary hardware and software coupling, provides standardized infrastructure and interfaces, supports distributed functions and software reuse, helps manage product variants through configurable architecture, and standardizes development descriptions so multiple companies and tools can collaborate more systematically. That is the real value. Not fewer engineering problems, better defined boundaries for solving them. Subscribe to keep following the course as these problem-solution pairs become the actual AUTOSAR architecture, layers, and modules. We have now discussed the problems and the technical framework, but AUTOSAR is also an industry ecosystem involving manufacturers, suppliers, semiconductor companies, software vendors, and tool providers. Lesson 15 looks at those AUTOSAR partners and the role each one plays. If you're getting something valuable from these videos, consider subscribing. It's just one click for you, but for me, it's a little reminder to keep learning and making these videos. Thank you.